Hi, welcome to your computer graphics lecture for week 2 of GD100. Today we're going to talk a little bit about color models, as well as I'm going to provide you with a short introduction to color theory and some tools that can help you with that for color models and color palettes. I'm also going to talk a little bit about production preparation for print and digital formats. Going along with that, image compression. Some of you have asked me some questions about that. We're going to go over lossless and lossy image compression and some file types that go along with that, maximizing your files for both print and digital production.
Alright, the first thing we're going to talk about is different types of color models and color systems. The three main types that we want to talk about are going to be RGB color platform, CMYK print colors, and then color books. Starting with RGB. RGB stands for red, green, and blue, and talks about the additive color model, which has to do with using those three primary colors to simulate the types of the human eye's color receptors, mixing these lights this is called additive color mixing. And it is the way that your television works, it's the way your computer monitor works, by taking these different colors of light and mixing them together as pixels to form millions of colors that your eye can interpret. So basically, to form a color with RGB, the three different colored beams are superimposed on top of each other. For example, they may be emitted by your computer screen, or projected onto a wall, or a white screen of some kind. So therefore, each of these color components mixes together at a different intensity in order to offset each other into what we call a mixture, and that mixture is the color that ends up on your screen. Now, the way the human eye works, when we see color as light, it's an additive process, meaning the light comes together, and where all the points of light intersect, R, G, and B, you get pure white light. The color model for printed or ink colors is completely different, and so we're basically taking solid objects, pigment, like you're painting, the same way you would take pigment if you were painting a painting or a house, and we're mixing pigment together to simulate the additive color model that light goes through. And so for print, the standard 4-color process is called CMYK, and that stands for cyan, magenta, yellow, and the K stands for black. If you look at the slide that I'm showing you now, if we were to take cyan, magenta, and yellow, we could mix them together to create a darker, kind of a muddy color. And there are some cheap printers that use that muddy color as a black, but it's not something that we as designers want to consider for a high quality printing. process. So the standard for high quality printing is CMYK. We add in the black so that we can get a true dark black color on our printed page. Now, the way this color model works is that each color, this is called a subtractive color model, or a subtractive color process. Basically, each color is applied to the page in a halftone pattern. I'm going to post the slide now. If you look up close at the halftone rasters, your magenta is being printed on top of your yellow, which will create to the eye an orange or red effect. And if you print the cyan on top of the yellow, it is appearing green, just like when you mixed poster paints in grade school. So it's that principle is being applied here, but in tiny, tiny dots. So if you look at this example of a halftone image, that's what a professionally printed advertisement or magazine, often if you look at it under a loupe, which is a little magnifying glass that designers use, you can see this halftone pattern and understand how these colors mix together. With halftoning, you can create a continuous range of colors if you include that black ink. Now, these colors, the color gamut for CMYK is going to be more limited than the RGB color gamut, because basically when you're dealing with pure light, you can create any color that the human eye can see. When you're dealing with ink, you're limited to the colors that you can physically mix together with those inks. And so you may see something like a fluorescent green is a good example on your computer monitor. When you send that off to the printer, you export it as a CMYK, you send it to your printer for him to print it. He puts it on the web press, prints it CMYK, you get it back, and it looks more like a hunter green or a pea green or a grass green. This is because the CMYK mixing process just does not allow for those bright fluorescent colors, because you're limited to the physical tones of the pigment. For this, as well as other reasons, such as consistency for corporate identities, the idea was invented to create color systems, or what we call in the industry color books. The most standard of which, and the one that you'll be hearing about most often as a designer, is the Pantone color matching system. Now, the Pantone system, often you'll see a little PMS before a number, and that tells you what number the spot color is. The difference between a spot color in CMYK is that a spot color is physical paint. It is you will have an actual canister of ink that is the Pantone paint color, and it is the same every time. So if you look up Pantone 7469, it's going to be the same teal every time you get it printed. So in order to help designers, you can order a Pantone color matching fan book that I'm putting on the screen now. this color matching system, the way it helps you is you flip to the color that you want to use in your design, and even if it looks different on your computer monitor than it does in your fan book, you know that when it goes to the printer and it comes out the other end, it's going to look exactly like it did in your swatch. And so that's why they're called spot colors, because you can print what they call a 5-color process, CMYK plus a spot color, or you could print, most printers, good web press could handle 5 colors. However, some printers only have slots for 2 colors or 4 colors, and so as designers, you have an opportunity to play with cost when it comes to which inks you're going to use. So you could use a Pantone color and black. Design your work in 2 colors, and then it'll save you money because you only have to pay for 2 inks, the Pantone color and the black, and then you'll know exactly what the finished design is going to look like. It's the same with a spot color added to CMYK. So you could have CMYK, and then you could pick a vibrant green as your spot color, and that way you can get that vibrant green that the CMYK just can't create. The other thing that comes in handy with spot colors is for corporate identity. So McDonald's has the exact same gold and red in all their ads because they print them with the exact same Pantone swatch colors. Anytime you're designing a professional logo for a corporation, you're going to want to carefully select a Pantone color, and that way they can have the spot colors on file in their marketing team, and when they get things printed, their logo will be consistent every time. Now they make tools. Pantone makes a tool, Adobe makes a tool, and there are many tools online that allow you to convert a Pantone color to RGB or to CMYK. But I want you to keep in mind that if you use these tools, it may be a close approximation, but it's not going to match exactly. You just cannot recreate a Pantone color exactly with CMYK or with RGB. It's just not going to be perfect. Since we do so much digitally now, we have no choice but to use cross-platform color models and to switch between the screen and a television screen, a computer screen, a mobile device, and a printed piece. And so your color variation is going to happen, but you can mitigate it just by calibrating your monitor and trying to look at the color on as many different devices and many different monitors and printouts as possible. The same with laser printers in offices now. The logo is going to look different when you print it on a laser printer than it is when you print it as a Pantone swatch color at a print shop. So those are just all things to keep in mind. I'm putting some slides up now, 2 different tools to help you as you start to learn about color theory. One is Kuler, which comes from Adobe, and just helps you to create different color palettes for corporate identity or for websites or other purposes. And there's another one from Aviary, which is called Toucan, and I posted screenshots of both of those, and I'll give you the links as well. Now, these tools can help you build color palettes, and they'll give you swatch colors, they'll give you hex numbers, which you can basically use to code websites with these hex numbers. And they'll give you an RGB number, which you'll notice is a standard way for digital color palettes. If you go into any Microsoft product, you can go to your More Colors palette, and you can enter in the red, the green, and blue color values, and then you'll get the same RGB color in all your software. And so it's a good idea if you're developing corporate identity to create color palette for digital as well as for print, and to try to color match as closely as possible so that you can have consistency. Consistency of brand is the main issue here, because again, McDonald's, you see those golden, that gold and that red, you don't even have to see that it's McDonald's to know the look and feel that fits with that company. Going along with color theory, I have posted an article to get you started on some of the basics of color theory, and it's on the main page under week 2. The other thing I want to talk about today, there's a little bit of production, print production. When you're getting ready to produce your file, and not just print production, but any type of production, there's no such thing as a final version. So what we do in our design methodology is we prepare the file until the deadline, we roll it out, and we always bring it back and test its effectiveness, and we manage improvements and roll it out again in a new version. So nothing is ever quite done. But when it comes time to create production files, that may mean different things for different media. If you're creating a production file for print, you may want to export it. You have to call your printer, whoever you're printing it through, and get their recommendations for the file format they need it, whether it be a TIFF or a PDF, an EPS file, or so on. If you're prepared the file for digital, it's going to be different settings depending on if you're preparing a photograph for web, or if you're preparing a document to be downloaded off the internet. So I just wanted to mention that if you keep printing, if you keep your final production in mind as you're creating your design, it saves you a lot of headaches in the long run, because you can build in your bleed, for example, which is a term that we use for printing, which is the area that may or may not get cropped off when they cut the, because usually printouts are printed on a large sheet, and I'm posting a picture of that now. And these printouts are then cut to size, and so when they're cut, the blade may move slightly as it goes down the stack, and so there's a certain area which is called the live area, which is where you want to put the things you definitely don't want to get cut out of the image, and then you have your bleed, which is an area that's okay if it gets cut off. And so if you're designing your graphic, try to build the bleed in based on the requirements of your printer beforehand, and that way you don't have to alter your design afterwards if your printer has strange or different bleed requirements. It's the same thing with web. If you're working with large photos, keep in mind file size and clarity, and what format you're going to have to export those in, and how much room it's going to take to download, how much time it's going to take to download. So just consider final production when you're working on your projects. For school too, it's important to consider, how am I going to talk about my work? I'm going to write out my design brief, I'm going to save it in a Word document, and I'm going to upload it in a zip file with my final project file. And that way, your instructors, they can't know what it is that was in your head necessarily when they look at your design, unless you give them a good overview of the work that you did. And a lot of times as designers, we have to just be able to justify the work that we did through our language. The last thing we're going to talk about today is compression. A couple of you have asked me questions about compression. We've had some good chats on the message boards about it, but I'm just going to post this image as an example of lossy compression. Basically, there's lossless compression, which is basically a zip file or other format that will compress any file down, and then you can uncompress it and then use the file again, and it's usable. And compressing it is basically a way to reduce the file size. Now there's also lossless compression, which is built into file formats such as JPEGs. If I'm working with a photo and I'm taking that JPEG and I'm compressing it down, it's going to be a really small file size. You could compress it down to 96% of its you could compress it down 96% so that it's 4% of its original file size. However, the image quality goes down greatly, and it's going to look awful. It's going to be, really not adequate even for web. But there's a balance. So basically, when you're saving a JPEG, there are different options to compress that JPEG. You're going to want to test different compression settings depending on what the picture is, because certain, a portrait, for example, you cannot get away with compressing a close-up portrait as much as you could, say, something more geometric. Geometric images often compress better, so you just have to play with it to balance out that file size versus image quality. So that's it for today, and thank you for listening. Let me know if you have any questions, and please enjoy your Inkscape tutorials that we've posted for this week, and they're going to apply to Project 2. Project 2, I really want you to just take some time conceptually to think about what you want to do. Daniel, his lecture on macro versus micro aesthetics and microaesthetic relationships will really lead the way to drive you when you're thinking about this project. I want you to just take the time to really consider these relationships in design, and how the different objects you put on the page affect each other, and sort of the attitude and the even emotional reaction that people will see as they view the shapes and type on the page. Try to do something personal and something that is meaningful to you, so that we can all enjoy it. Also, as a word of note, when you're uploading your projects as a zip file so that you can include a project brief or a design brief with it, if you would not mind me sharing your work with the rest of the class, I can post it in our graphic design lab, and we can all look at it, critique it, and enjoy each other's work and the emotional reaction and design reaction that we get from it. So, thanks for listening.